Hi, this is Peter, and this is a brief tutorial for using my application StratVis with the Kaymakci Archaeological Project database. So StratVis is a software for visualization and editing of stratigraphic relations, especially for identifying and fixing cyclic relations in stratigraphy. So before we begin using StratVis, we need to export data from the Kaymakci Archaeological Project database, from the Gaigeia database. For this, we use this software Gaigeia to deposit, which is along with StratVis and the software changes to be Gaigeia installed after installing the StratVis package. So I started the idea to deposit program. It's just a simple dialog where we enter the host. This is the connection to the PostgreSQL server. So we enter the host name, port, the database name. Here I use a database which is on my local computer, and username and password. I also have to choose a deposit database since StratVis uses the deposit database software internally. So I have to export the data, the stratigraphy data from the Gaigeia database to the deposit database. So here's the format used is Pickle. So deposit supports different formats. This one is has the lowest footprint and is quickest to save and load. So when everything is set up, I click export, and I get feedback here: how many stratigraphic relations have been found, how many contexts, and in how many areas. So I can close this, and now I can open the database in StratVis. So I start it, and here I'm presented with a dialog to select the data source. So I use the Pickle format and here select the database I have just exported. Click connect. It loads automatically. So what we see here is I can specify the class and descriptors which are used for the features and the areas. If you used the Gaigeia to deposit application, it will be automatically these default names for these classes. So I don't have to change anything. And here I can select which area to visualize. So here it's the area 81551. And using the mouse wheel, I can zoom it in and out. You see, in this form, it's quite a complicated graph. This is a so-called directional acyclic graph, or DAG, which shows I can use the right mouse button and drag it. So I click and hold the right mouse button and scroll it, and mouse wheel to zoom it. And you can see generally this graph tries to organize the features. So these are the unique features, the nodes of these graphs. I can left click and drag it to move it around. It tries to organize them in a way that the directions of the edges or the stratigraphic relations go up. So here you can see, for example, that feature 8155144 is cut by feature 8155151, and so on. So what I can do to simplify the graph a little is to collapse contemporary features. So features which have relations like here included by. So these two features have a stratigraphic relationship, a relation which indicates that it's actually one stratigraphic unit. So I can use this collapse contemporary option, which combines these features into stratigraphic units. you see some edges are, or some relations are displayed in red. These are the ones that are circular. So the software detects circular relations. If let's say we cannot have so relation A is cut by feature A is cut by feature B, and that is cut by feature C, and then again feature C is cut by feature A. So there is a cycle, and that cannot logically exist. Usually these cyclical relations are a bit more difficult. It can also be that two features are designated as contemporary, but also have a stratigraphic relation, which suggests that they are in a stratigraphic sequence. So let's see. For example, here we have this combination of features. So these features 815518 and 815514 have a stratigraphic relation covered by, which means that this feature should be older than this one, but they also have stratigraphic relations to this set of features which form a stratigraphic unit, which suggest that they are contemporary. So they are this feature is the same as this unit, and this feature is included by this unit. So there shouldn't be such a relation. So one of these three relations is wrong. What I can do is simple. If I say, okay, this same as relation probably is not correct, I can just click here to remove the relation, and theoretically that would resolve the relation, the cyclic relation, if there wasn't another. There is probably another problem with the stratigraphy, which still causes a cyclical relation. What I can do is I can double click the feature which opens the deposit database in the background, and here I can look at the details. This is the entry, the record for this feature. If I double click it again, open it, maximize this, I can see here all the relations, all the stratigraphic relations. So there is some covered by relation and also an included by relation. So probably there is a problem where there's a chain of stratigraphic relations which cause a cycle in the end. So further deeper research would be necessary. So let's say I can resolve this very easily by just deleting this relation, which is detected as cyclic. Okay, that resolves this problem. So in this way, I can just edit the relations. I can also create new relations by selecting one feature and then holding the Control key and selecting another feature. And here now I can select Add Relation. I can decide in which direction the relation goes. So let's say if I want to indicate that feature 22 is cut by feature 33, then I have to click Switch here, and now OK, and this creates a new relation that between these features. I can also decide to reverse relations. So let's say I say that this relation is in the wrong direction. It should go the opposite way. I just click reverse relation, and I can see here it already resolved some of the cycles. There is also an option to only show features which have circular relations, which should theoretically simplify things. So I can have a look at all features involved somehow in the cyclic relation or circular relation. And also there is another feature that calculates once, let's say I should have all the circular relations resolved, and then I can use this sort by phasing, which modifies the sorting slightly. It calculates archaeological phases. So the epsilon coordinate in the graph should indicate a phase now. So which is sometimes it can be, of course, uncertain. For example, for this feature here, it's probably it could be like, let's say, between those two features here, or even it can be in all the phases between this feature and this feature. So this could move, but generally this should offer us a sort of more Harris matrix like view, or maybe uses it can be used as a tool to construct a proper Harris matrix once all the relations are fixed. So in this way I can just, if I select a different area, this one is quite large, and do the same. There is also an undo function here, so I can reverse what I have done. Okay, and so once I am finished, one thing I can do is save the database in this deposit format. So I can maybe continue working on it later. So I can do this just like this. And what's very important, after I'm finished working or fixing the database or modifying it, I should also export the changes. So there is this function, export changes as XLS, which creates an Excel file listing all the changes to the stratigraphy I have made, which can then be imported back into the Gaia database. So I do this, I select where to save these changes. Data. I can choose whether to save this as an Excel workbook or a CSV file. So this is one thing, and I can also export this stratigraphy either as an Excel file. So this will export all the stratigraphic relations as an Excel spreadsheet, or I can export this stratigraphy, basically this graph here, as a PDF file. But let's not do that right now. So okay, so let's say I have fixed or I have somehow progressed in fixing the database, the stratigraphy. So I can close this now. Save changes, yes. And now I can re-import those changes into the Gaia database using this changes to Gaia program. And here again, I have to specify the database connection details. This is, I have to select a backup file. So every time I import the changes, a backup is created. So in case I do something wrong, I can just restore the database back into the original state. So it's like a fail-safe. And here is the changes file. I can just select it, or it will always remember the last one used. And I click import changes. I did something wrong. Let's connect to the Gaia database. Wrong password. Okay. Changes. It asks me if I'm sure to apply for changes to the Gaia database. Yes. And also we can have a look how this Excel file looks like. These changes that I have exported. It's a simple spreadsheet saying which action was done. So removal of relations or adding of relations, source feature, the relation type, and the target feature. Okay. So this file was used now to automatically update the GAIA database, and if I were to again export the database, let's do this to export and open it. We see already this cyclic relation here that was present before is already gone, so because the stratigraphy is updated in the main database. And also, if I want to continue working on the previous exported database, so these two are now identical since I have saved the changes here and I have re-imported the changes and then exported the database again. So I can just open it and continue working, and then again once I am happy with the edits, then I can export the changes and again import them into the main GAIA database. So this concludes the tutorial.